thought I'd follow up on the 0 on 0 thing. So in the previous video, concluded that 0 on 0, plausibly, is a problem in math. It's definitely a problem in math because it can literally be anything. It can be any number, and it can at the same time not be a number at all. Right? And I showed this in a couple different ways. Also, that the numerator doesn't matter. It can be any value, because what we can do is we can multiply this by something, and it's still itself. Right? We ended up with an identity for that. So the numerator can be anything. So really the problem is division by 0. It doesn't matter what the numerator is. It's division by 0. Anything divided by itself, including 0 divided by 0, should be 1. That's true. As your denominator grows smaller and smaller and smaller, we get closer to infinity. So that is also true. So it is simultaneously acting like infinity. It is acting like 1. 0 divided by anything should be 0. Yes, that's true. So this should also be 0 at the same time. And we can show that it can literally be anything. And it is everything simultaneously. But also, it can be not even a number, right? Basically, in that situation, it's telling you that the question you're asking doesn't even make sense, right? And the example of this that I showed was with the tangent of pi on 2, right? So the tangent is, you have a circle, and let's get a nice circle here. And what we're doing is, from the center, we're drawing a line, and then 90 degrees to that, we're setting a line on the circle. And we are measuring how far from this junction here to the x-axis. So it'd be like from here to, say, here. It'd be, say, like this length right here. That length is the tangent. So say that's our x-axis. That was crooked. At x on 2, so we've got a 90-degree angle. Say my thumb is our line, and pretend that's all perfectly oriented. Our tangent is going to be exactly parallel to the x-axis. They're never going to meet. So this tangent does not have a length. And the reason this is a division by 0 problem is because the tangent is on that triangle. It's the side opposite our angle divided by the side next to our angle. And here the side next to our angle is a 0, so we get a 0 in the denominator. In this case, we would get a 1 in the numerator. It doesn't matter what the numerator is, really. The problem is that we have a division by 0. So with this weird situation where we're asking what is the length of this line before it hits the x-axis, we get a division by 0 simultaneously with the fact that this question doesn't even make sense. There is no length that can be measured. So division by 0 can produce absolutely any number and no number at all at the same time. It is all, and importantly, it is all of them all at once. And I also showed that, but I'm not sure if it was clear that I showed that. So another example that I wanted to show it with is, say, so I showed it with y equals x. Let's try it with something like y equals x squared. And this might not work because I just thought of this in my head a minute ago. I haven't tried this, but I think this will work. Okay, so the trick that we did when it was just y equals x is if you multiply by 1, it's going to be the same thing, and this is 1, right? Because anything divided by itself is 1, so I can replace the 1 with this, and then we can work with it from there. And we can do the same thing here, right? So y equals x squared, that should be the same as y equals x squared times 1, right? And the graph of this guy, so it's gonna hit at our origin right there, and it's gonna come up like that, give us a nice parabola. And it's gonna come up like that, give us a nice parabola. So it doesn't exist down here, right? It doesn't exist at all. The y values, there are no y's down here. Y down at this area, there is no y value. Y doesn't exist down there, right? So this is where it's going to get interesting. Here, if I replace the 1 with something that can act like this, say we pick some point M once more. So let's say right there. This is going to be M squared. Right? So whatever my x value is, y is the square of that. Right? So here x is m, so y will be m squared. Okay? I want to drop a hole into this graph at this point. So what we're going to do is we're going to turn the 1 into x minus m over x minus m. Same thing that I did with the straight line. But for the straight line, y exists everywhere. So there was a case there that was missing. Here, we're going to catch all of it. We're going to catch where y doesn't have a value. And it's still going to be described by this guy. Okay, so same trick as before. At m, this is going to be 0 over 0. Right? So for x equals m, we get 0 and 0 being multiplied here. We know what it should look like. We know what its limit is. Right? But we can play with this. So let's kind of take both of these together. So if we get this, y is x squared times x minus m on x minus m. Right? For this specific case where x is m, we're going to get y equals x squared times 0 on 0. Now again, there's two ways to approach this, just like last time. X squared, we can just handle the numerator, right? And we get y is the quantity x squared times 0 over 0. Well, the numerator is going to be 0, so y is 0 on 0. Or we can recall that anything times 0 over 0 will give us 0 over 0. So it doesn't matter what this is, we're just going to get 0 over 0. And that agrees. Importantly, these two agree. So wherever you think this might be going wrong, it's in agreement with itself. So, okay. Now, this is not sensitive to what value our x is. All this is telling us now is where y lives, right? Where we don't care about x. It's like we took all of the x and just collapsed it. And we're only looking at what y can possibly be. Normally, when you look at this, you would say that y doesn't exist below 0. There's nothing here, right? But this nothing is something that 0 on 0 can be. So this is actually describing everything that's happening here just fine. Not usefully. You can't get any information really out of this, other than our y-axis is not broken. That's all it's telling us, right? That the y-axis continues to positive infinity and negative infinity. That's really all this means. It doesn't tell us anything about where we're getting values for y, because a non-value is also something that 0 on 0 can be. 0 on 0 can literally be anything and is simultaneously everything. Because here, y, not only can it be anything, it is everything. Because that's what this is. This line is that entire continuum of everything. That's what this is telling us. I feel like I maybe didn't make that clear in the previously, but yeah. So that's why you can't divide by 0. It's not that it's undefined. It's not that it's infinity. It's not that 0 on 0 is 1. It's not that 0 on 0 is 0. It's that 0 on 0, or anything on 0, is simultaneously everything, including not even a number. It's every number and not a number at the same time. You cannot pick out a value for it.